All right, so we're going to do a little bit of geometry. So section R3 is all about geometry. I think I broke it down into maybe 3 different sections. So the first one is Pythagorean theorem. So let's talk about that. Pythagorean theorem is only used with right triangles. So I'm going to draw me a right triangle right here.
So we're doing shapes?
Yes. All right, so here's a right triangle. That little box right there means it's a right triangle. What does that box mean? It means it's a certain number of degrees. How many degrees is that? No, it's not less than 90. It's exactly 90. That little box right there means it's 90 degrees. So that angle is 90 degrees. So this is considered to be a right triangle. Because this is 90 degrees, and we also call it a right angle. Okay, 90 degrees. All right, that wall and this floor comes to a certain angle right here. It makes a 90-degree angle, hopefully, if the building was built correctly. All right, the floor and the wall is a 90-degree angle. Okay, the ceiling and that wall is a 90-degree angle. These 2 markers right here, they're at what? 90 degrees. Do you see it? See that little, could put a little box right there? Those are 90-degree angles. So that's a right triangle. So Pythagorean theorem, we'll talk about that in a second, only deals with right triangles. That's super important. So if I had a triangle that looked like this, can you use Pythagorean theorem to solve for anything on this? No, because it's not a what? It is a triangle. It's not a right triangle. Very good. All right. It's not a left triangle. That would be an acute triangle. We're not going to deal with that just for now. I don't know if we ever will in here in this class. We're only going to do a little bit of geometry. So this would be an obtuse triangle because this angle is an obtuse angle. The other one that I erased was an acute triangle because all the angles were acute, less than 90. This angle is more than 90. That's obtuse, but I don't really care about either of those with this situation right here. So let me just, I'll do this. A lot of times when you use Pythagorean theorem, they use the letters A, B, and C. When I talk to people about Pythagorean theorem, I'm like, Pythagorean theorem is as easy as ABC. Why do I say that? It's not because it's that super easy. It's just because you have the letters A, B, and C in it. Okay. Now you could call them anything. You could call it X, Y, Z, P, R, Q. You could have used any letters that you wanted, but that's what we kind of usually use is A, B, and C. All right. Now, the A and the B, they always talk about the legs of the triangle. All right, so B is a leg and A is a leg. So these are the legs of the triangle. Okay? Go ahead. Lana, what did you say? That's right. C is always the hypotenuse. Let's talk about that for a second. All right? The hypotenuse is always opposite of the right angle. All right? Again, you can use any other letters. You don't have to use A, B, and C, but for the vast majority of people that learn Pythagorean theorem, they usually use A, B, and C. This has got to be the hypotenuse because it's opposite the right angle. See, here's the right angle. See how it's across from it? See, this A, it's actually connected to the right angle. This B is connected right here. You see that? To the right angle. The C is not connected to this right angle at all. All right, so it's opposite of the right angle. So the hypotenuse is always the C. You got it? The hypotenuse is also, there's something unique about the hypotenuse on a right triangle. It's always the longest side. You didn't know that? Is that what you said? Okay, the hypotenuse is always the longest side of a right triangle. Now, you can only have a hypotenuse when you have a right triangle. Why is that? Why can't I have a hypotenuse on an obtuse triangle? I have a longest side on an obtuse triangle, but it's not called the hypotenuse Because the hypotenuse is always opposite the what? The right angle. Okay. So those are some very, very important things you need to know about the right triangle before we even start talking about the Pythagorean theorem. Everybody got that straight? Yeah. Okay. So I think I've covered everything. So now let's draw another right triangle without all that mess around it. Nope, missed that one, didn't I? There we go. And let's put a little right angle thing right there. So that's a right triangle. Would you ask? Is it acute what?
No, I was just saying, like, what about the other sides?
You mean angles?
Yeah.
The other angles, they would be acute angles. Right, on a 90 degree triangle, right, or right triangle, the other two angles will always be acute. All right, they're always less than 90 because now you don't have to know this to do Pythagorean theorem, but what do all three of these angles add up to be on any triangle? 180, right? So if this is already 90, then this angle and this angle have to add up to what? To 90, all right? And anything that adds up to 90, they got to be both less than 90, correct? All right, so these are acute. Both of these angles are acute. All right, but that's not really, we don't need to know that. It's good geometry to know, but it's not really part of Pythagorean theorem. So here we go. What if I gave you the length of that side was 3, and I'm going to make this as easy as I possibly can to start off with, okay? And this side right here was 4. This is actually a special kind of right triangle, but you don't need to worry about that right now. With the Pythagorean theorem, which I haven't even shown you yet, with the Pythagorean theorem, I will now be able to solve for side C. All right? Now, right now, if you didn't know the Pythagorean theorem, there's no way that you could solve for it. But here's what the Pythagorean theorem says. I'm going to write the word down again. By the way, I didn't say this. Pythagorean theorem. Now, a theorem is just a fancy way to say it's a rule, R-U-L-E, or it's a law, okay, or something like that, okay? It's just something that we know is true. In geometry, we talk about theorems. We say we can prove a theorem, right? So we can always prove this. There's a bunch of proofs out. In fact, just a few years ago, there were these girls from this, I think it was an all-girls Catholic school down in Louisiana, and they came up with a brand new proof of the Pythagorean theorem that nobody ever thought of before. They made the news and all that. If you look them up, put high school girls prove Pythagorean theorem, and you'll see that these two girls, and they came up with this proof. Kind of interesting stuff. But anyway, there's all kinds of proofs for it. We're not going to do that. I'm just going to show you what it is. Here it is. When I say it's as easy as ABC, it's this. It's a squared plus b squared equals c squared. Right? It's pretty simple, pretty elegant. All right? It's ABC, right? A squared plus b squared equals c squared. Notice where the c is. The c is always the hypotenuse, right? It's always by itself. It's the two sides that are being squared and added up. So I always take the two sides, or I shouldn't say sides, the legs, the two legs of the right triangle. Square them, add them up. It's always going to equal the square of the hypotenuse. You ever watched or heard of the movie The Wizard of Oz? Has anybody watched The Wizard of Oz? Okay. There's a part in there where the scarecrow, is he the one that gets the brain? Yeah, he's the one that gets the brain, right? Anybody? Yeah? You don't remember? You don't remember? Nobody remembers Wizard of Oz? Anyway, there's a thing in here. Maybe after the class is over, or after this lesson's over, maybe I'll show you the video. But there's a thing. There's a part where he recites the Pythagorean theorem, okay, in The Wizard of Oz, in the movie, because he gets the brain, right, and he's supposed to be real smart. First thing he says is basically the Pythagorean theorem. He doesn't say a squared plus b squared equals c squared. He says something about the square of the hypotenuse is equal to the sum of the squares of the other two sides, right? That's supposed to make him super smart, right? But it's Pythagorean theorem. It's kind of interesting. That was in I think that was made in 1939, all right? 1939. It's getting close to almost 100 years. It's like 90 years ago. But anyway, I thought that was kind of interesting that they actually recites the Pythagorean theorem, and that's what they thought of to make him sound really smart when he got the brain, because apparently he didn't have a brain. Who didn't have the heart? The Tin Man, right? See, he didn't have a heart or something? Yeah. Lion, no, not the heart. Yeah, was it the heart? No, the lion got the heart, didn't he? What did the lion get? Oh, he got courage or something. I don't know. I can't remember. Anyway, there we go. So let's do this. So which ones are my A, my B, and my C? Well, that's the C. That's pretty obvious. The 3 and the 4 are the what? The A's and the what? And the B's, right? Because they're my two legs. They're the ones that are not the hypotenuse. Got it? All right. So what we're going to do is we're going to plug it in, and then we're going to find what C is equal to. So let's do that. So I'm going to use A squared. What's my A? What's A? It's 3. So I'm not just going to go 3 plus 4. What do I have to do to that A? I got to square it. Plus, and then what? B, which is 4, and I have to square that. And that's going to equal C, which I don't know, so I just leave it C, and I got to square that as well. Right? It's just plugging stuff into the little formula. All right? That's not so hard, is it? Right? You just take that 3, you plug it in, take the 4, you plug it in, and now we got to do some work. So what is 3 squared? 3 times 3? It's 9. Plus 4 squared. What's 4 squared? 16. Equals what? Well, equals what? What do we write? What do I write down here? No, I write down what? Come on. What did I write down? C squared, right. Okay, I write C squared. So I'm going right along here. Okay, 9 plus 16 equals C squared. Now I can do this. Now I'm ready to work on this a little bit more. So what's 9 plus 16? Now you can say it. It's 25. And then equals C squared. So is that my answer? So does that right there, does C equal 25?
No.
Question mark?
Square root.
Correct. Let's get rid of this mess. Whoops. Okay. So now, C squared equals 25. So I got to get rid of the squared. I just want C by itself. So I have to get rid of the squared. So I have to do the opposite. What's the opposite of squaring something? Square root it. That's right. I got to square root it. So if I square root C squared, watch this. If I square root C squared, the squared goes away. That's what I wanted to do, right? I wanted to get rid of the squared. But if I square root one side, what do I have to do to the other side? If I do something to one side, I got to do what? The same thing. So listen to my question. If I square root this side, what am I going to do to this side? Square root it. Okay? Now again, what happens when I square root a squared? They cancel out, right? So that is C. Now, what is the square root of 25? What number times itself is equal to 25? What number times itself is 25? It's the only thing that multiplies to be 25, except for 25 and 1. Amir, tell me. It's 5. 5 times 5 is 25. Okay. So that's my answer. Now, I wrote 5 equals C. Might be a little bit nicer if you put C equals 5. And then there you go. So that's what that length is right there. So if I was building something, all right, maybe I was building, I don't know, some kind of a deck or something like that, and I knew that this was 3 yards and this was 4 yards, and I got to figure out, okay, I need to figure out what this length's going to be right there. Okay, how would I do that? I would use Pythagorean theorem. All right, so I go 3 squared plus 4 squared equals C squared, do the math, and come out to be 5. So this would be 5 yards. All right, if I was building something, that could be very, very helpful. People use that stuff all the time. They do. Now, that was about the easiest one because it came out to a nice whole number. They're not always going to come out to be a nice whole number. All right, let me find, that's the only example they give for that. Let's do, okay, thank you. Let's do another one. Sometimes they come out not so pretty. So let's do one before we go to something else. Tell you what, I've been making these look, I'll just switch it up a little bit and make it look like that. Is that all right? Is that still a right triangle? Well, it's a right triangle if that's a right angle, okay? If I didn't put the little box there, you wouldn't know it was a right triangle. It could be like 89.999 degrees, right? Which is not technically a right triangle. It's really close, but it's not. But if I got the little box right there, yeah, that means that's a right triangle. What if I made that 5? Now, let's make this 5. Let's make this 2, okay? And then I wanted you to solve for C. So let's do Pythagorean theorem. Let's write it down. Have you memorized it yet? You should. It's pretty easy. It's easy as what? It's as easy as ABC. So it's a squared plus b squared equals c squared. You know, you could write it the other way too. You could write c squared equals what? A squared plus b squared, couldn't you? Isn't that the same thing? Let's use this one. It's the same thing. Why would I use this one and not this one? Because remember the other one, we said 5 equals c right there. This one, since I'm solving for c, it'll be on the left-hand side already. I don't have to worry about switching it around. All right? So what are we going to put in here? Well, I don't know c, so I'm going to write c squared. Now, it doesn't matter which one you call a or b. All right? It makes no difference. If I wanted to call that one a and this one b, that's fine too. It doesn't make any difference. So let's do that. So a squared. So what do I got? 5 squared. Plus b squared. B is 2 squared. See what I did? Just plugged in my a and my b. Now I got to square them. 5 squared is? We've done this one already. What's 5 squared? 25. Plus 2 squared. What's 2 squared? It's 4. So c squared equals 25 plus 4. What's that? It's 29. Now c squared equals 29. Does that mean this length right here is 29? No. So I have to do what? I got to get rid of the square. How do I get rid of that square? I square root. So I square root this side and I square root that side. The square root does what to the square? Cancels them out. So I got c equals, square root of 29. What number times itself is equal to 29? Amir, say it. I know, say what you were thinking. Right, there's nothing, all right? There's nothing times itself, at least no whole numbers. There's no whole number times itself that's going to be 29. Would you agree with that? It's 1 times 29 and that's it, right? 29 is a prime number. So the only way I can write it is like this. Just keep it the square root of 29. And that's perfectly fine. A lot of kids that first learn this, they want to make it some other kind of number, okay? I don't know why. But it's perfectly fine to keep it the square root of 29. Now, it is a number. It does, there is a decimal for it. So watch this. The square root. My square root button is right here. The square root of 29. Now, the square root of 25 was 5, right? What's the next one up? Square root of 36. What's the square root of 36? 6. So 29 is between 25 and 36, isn't it? So the square root of 29, once I hit enter, should be somewhere between 5 and 6. It's probably a little closer to what? It's probably a little closer to 5 because 29 is not that far off from 25. It's a lot closer to 25 than it is 36, isn't it? Guys aren't listening, are you? All right, hit enter, there it is. It's about 5.38, let's say 5.4. So that's approximately 5.4. I do not want you to put it into a calculator and give me a decimal. Just leave it like that. I'm perfectly fine. In fact, I insist that you leave your answer the square root of 29 in this particular problem. Does that make sense? Yeah, it's not so hard, is it? All right, enough of that. Now we got a little bit more to do. Now what I'm going to do is I am going to go backwards. So the Pythagorean theorem said this. I didn't write it down like this. So here's what the Pythagorean theorem basically says. If you have a right triangle, I'm going to leave out some of the words. I'll keep the important ones. If you have a right triangle, then, so you start off knowing what? You start off knowing that your triangle is what kind of a triangle? A right triangle. Okay. Then, if it's a right triangle, then what do you know about the sides? Then you know that if I take the two legs and I square them, add them up, it's going to equal the hypotenuse squared. Right? If you have a right triangle. What if you didn't know your triangle was a right triangle or not? So this is called the converse of the Pythagorean theorem. The converse of the Pythagorean, I'll shorten this, theorem. The converse, you switch the if and the then. So instead of saying, if you have a right triangle, then a squared plus b squared equals c squared. What's the converse going to be? If what? If a squared plus b squared equals c squared, then your triangle, or it's a right triangle. I'll use the symbol for triangle. Is that all right? You with me on this? So if they gave you three sides, they're going to ask you this question. They're going to say, is it a right triangle or is it not a right triangle? I think that's all they ask you. I'll have to look to see, because there's something else I could teach with this too. I didn't put it in my notes, so it probably wasn't in the book. We'll probably just leave it like this. So here's what they're going to give you. Here's an example. This is example 2. We just did example 1. Here's example 2. If they give you the side lengths of a triangle, now they don't tell you that this is a right triangle. The side lengths of a triangle is 5, 12, and 13. I want to show if it is a right triangle. All right? So I don't know it's a right triangle right now, okay? But they tell me one of the sides is 5, the other is 12, the other is 13, okay? Remember, the c in a squared plus b squared equals c squared, c is always the what side? The longest side. Now, if I don't know if it's a right triangle, I can't call it the hypotenuse, but I know it's the longest side, okay? So out of these three numbers right here, which is the longest side? The 13. So I'm going to make that 5 the A, I'm going to make the 12 the B, and I'm going to make that 13 the C. Why can't I make the the 5 the C? Why can't I make that the C?
Because 13 is bigger than 5.
Right, because it's not the longest side, is it? Why can't I make the 12 the C? Because 12 is not the longest side. So that's why I make the 13 the C. All right, the 13 has to be the C. So I want to determine if it's going to be a right triangle. Instead of writing a squared plus b squared equals c squared, I'm going to write it the other way. I'm going to write c squared equals a squared plus b squared. I'm doing that for a reason. Okay, I'll keep those numbers there. So let's plug the numbers in and see if c squared actually equals a squared plus b squared. If they do equal each other, then it's a right triangle. Okay, so let's try it. What's the c? 13. And then what do I have to do to that? Square it. Equals, what's my A? It doesn't matter. It doesn't matter which one, okay? 5 or 12. So we'll call it the 5. All right? You could call it the 12. It doesn't make any difference. But I got to square it. Plus, then I take the B, which is the other one, which is the 12, and I got to square that. Now, what am I trying to do? I'm trying to see if they're equal. If they are equal to each other, then this is a what kind of a triangle? It's a right triangle, okay? If they don't equal each other, it's not. So what I'm going to do, I'm going to put a little question mark on top of that equal sign. Is that all right? Because I don't know they're equal just yet until I do the math. All right, so let's do the math and see if they're actually equal. 13 squared. You probably don't know that off the top of your head, but that's 169. Equals 5 squared. You do know what that is. We've done this a third time now. That's 25. 12 squared. You know 12 squared? 12 times 12? Yep, it's the last multiplication table you usually learn, right? It's 144. Now, again, this is all question marks. Are they equal to each other? What's 25 and 144? That's 169. So, is 169, easiest question all day, is 169 equal to 169? Yes, it is. Of course it is. So, guess what kind of a triangle has side lengths 5, 12, and 13? A right triangle. So, your answer is yes. It's a right triangle. It's not a matter of guessing. If I ask you a question, is it a right triangle, is it not a right triangle, and you just say yes, and you didn't show me any work, I'm marking it wrong. You hear me? Excuse me. So you have to show how you got to that conclusion. What if you did something and this was not equal to 169? Then there would not be a right triangle. Make sense? All right, I think that's everything. So let me write down what the assignment is. Do we have homework? I'd put the lesson plans up on the screen. Well, I told you to. All right, so we're going to call it R3A, and it's page 36. I'm about to write it down. Why would you ask me that? I'm in the middle of writing it down. Oh my gosh. I'll give you more if you'd like. Maybe I'll take off the odds and make you do all of them. Okay, I'll do that then. So you're going to do them all. All right, there you go. Hmm? All right, there you go.